is like a huge topic. So sinusoidal PWM is just like one modulation technique that it's used for three-phase inverter. A more commonly used modulation technique nowadays is space vector modulation. I'm gonna provide videos for that later after the final exam. So that's only gonna be like for your own studies, for your own interest. But one thing I wanted to tell you, and I have mentioned this in other videos before, is the application of three-phase inverter combined with three-phase rectifier for controlling AC motors. Okay, so let's say like this is our grid. We have three-phase ABC. Okay, and we want to control this three-phase motor. Now, controlling AC motors like induction motor or synchronous motor, it's not as simple as controlling DC motors, because if you remember, we discussed when we discussed choppers, we saw that, for example, with a 4-quadrant chopper, we can control the speed of DC motor very easily. We can increase the voltage, and by increasing the voltage, we would have like higher speed, and we can reverse the polarity of the voltage and current. So like you can just like have the motor rotating in opposite direction if you want. But for AC motor, it's not that simple, because the speed of the motor would be determined by the frequency that you supply it with. Now the frequency of the grid is fixed, 60 hertz or 50 hertz, so it's going to be fixed, so we can't change the frequency of the grid. So one thing that we do is using something called drives, motor drives. Okay, I'm just gonna draw this very simple. So we're gonna have, first of all, a rectifier here. A three-phase rectifier here. Okay, so this would just rectify the voltage. Now we would have a DC voltage here. You would of course need to filter this out to make sure that it doesn't have harmonics. Now that we have a DC voltage, we can convert it, or we can control it using inverter to create an AC signal with any frequency that we want, with any voltage that we want. So using PWM, we can control the frequency and the voltage of the three-phase that we want to supply our motor with. So what we're gonna have is basically having, let me draw a capacitor here. This is we already have a capacitor. So like this part is the rectifier part, which converts AC to DC. And now we want to convert DC back to AC, but let's say with a variable frequency. So like these are called like variable frequency drives. Like you can change the frequency of the output. So what we're gonna have here, it's gonna be an inverter. Let me just like draw switches like this. Sorry. And this is going to be A, this is going to be B, and this is going to be C. So we're going to just supply the motor with these voltages. Okay, so I mentioned that the combination of rectifier and inverter is used in motor drives before, like, but I wanted to draw you what the, like, a general overview of a motor drive is. You would basically have a rectifier with a, like, a capacitor, and then you would have an inverter that would just provide the variable frequency AC voltage that we need to supply our motor. So you can control the speed of the motor by changing the frequency. You can also like change the voltage using the PWM. So this is what I wanted to share with you regarding three-phase inverter. If you have any question, I'm gonna answer your questions later. So that would be it. I'll post more videos later on regarding space vector modulation, and also what happens if there is a dead time. We discussed that for a single phase inverter, but that's even more important for three-phase inverter. What if we have dead time between the switches? We assume that as soon as this goes on, this would go off, and the same thing for other switches. But what if we have dead time? What's going to be the impact of that, right? And so all the best, and that's it for three-phase inverter for this course. Thank you.